Assalamu alaikum, dear students. Today our topic is group 16 elements. The elements of the group are oxygen, sulfur, selenium, tellurium, and polonium. These are collectively called oxygen. The elements of the group are called oxygen family as they follow the element oxygen. They are also known as it is pronounced as alkegens, meaning ore producing elements, because the metallic ores generally exists as oxides and sulfide minerals, exist in oxide and sulfide minerals. Now why these are called the members of the family, why this group is called oxygen family, because their first element is oxygen. They are also known as alkegens, or which is read as CHAlCOGENS, because they are ore producing elements. The first two elements, that is oxygen and sulfur, they are typical non-metals, whereas selenium and tellurium are essentially metallic, non-metallic, but they show characteristics of metals as well. So they are called metalloids. Whereas the polonium is a metal, it is radioactive in nature and has very short half-life period. Now the occurrence. The occurrence of the elements of group 16 elements. The first element, which is oxygen, it exists as the diatomic molecule. Oxygen, it is most abundant element, and it occurs in the free state. Oxygen occurs in free state as O2 dioxygen. It is the most abundant element. It makes up 20.46% by volume of atmosphere, (23% by weight of atmosphere), and it makes up 46.6% by weight of Earth's crust in the form of silicates, and it makes 89% by weight of water in oceans. This is the abundance of the oxygen. Sulfur is less abundant than oxygen and is the 16th most abundant element by mass in Earth's crust. This sulfur occurs up 0.1 to it occurs up to the occurrence of this sulfur is almost 0. It is not 0, it is 0.03 to 0.1%, and it exists in the form of sulfates, e.g. gypsum. CaSO4, 2 times water, Epsom salt, MgSO4, 7 times water. It occurs in the form of sulfides like PbS, lead sulfide, which is called galena, and zinc sulfide, which is called zinc blende. So this is the occurrence of sulfur. After the occurrence of oxygen and the sulfur, selenium and tellurium are very rarely found. Their abundance is much less than sulfur, and the abundance of selenium is 0.005 ppm, whereas tellurium it is 0.003 ppm, and that of the polonium is 0.001 ppm parts per million, and this polonium is obtained by the disintegration of the radioactive elements, that is thorium and uranium. Here we have the selenium, it is not 0. It is 0.05 ppm, it is abundance in the Earth's crust, which occur in the form of sulfides. Selenium occurs in the form of selenide, while tellurium telluride, right? So these two are the sulfide ores, very least abundantly found in the Earth's crust, and the radioactive element polonium obtained by the disintegration of the radioactive elements like thorium and uranium. And its existence is very little, that is 0.01001 ppm parts per million in the Earth's crust. It has a very short half-life period. Now we have, after their occurrence, we have their electronic configuration. Electronic configuration. Element, atomic number, electronic configuration. This is complete. With noble gas core. The first element is oxygen. Its atomic number is 8, and its electronic configuration is 1s2, 2s2, 2p4. But we must bear in mind that the outer shell electronic configuration of the group 16 elements is ns2 np4. So the first is 1s2, 2s2, the oxygen, it is 1s2, 2s2, 2p4. We will write it with the noble gas core, that is helium. Its atomic number is 2, and 2s2, 2p4. Number second is sulfur. Its atomic number is 16. We have to add 8 to the oxygen, so it becomes 16. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p4. So we have, this is noble gas core, neon. Atomic number of the neon is 10, 10. Then we have 3s2, 3p4. Number third is selenium. Its atomic number is, we have to add 18, that is 34. The electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. Here it was incomplete third shell. It is complete third shell, so we have 3d10, 4s2, 4p4. If we count the number of the electrons, that is 2, 4, 10, 12, 18, 28, 30, 34. Now this is argon. The atomic number of the argon is 18. Then we have 3d10, 4s2, 4p4. 18 और 10 हो गए 28, 30, 34. Number 4, tellurium. (34) and 18 हो गए 52. Again we have third shell complete, and in the fourth shell we have also the complete d orbitals are completely filled. So it is electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 5s2, 5p4. So this is electronic configuration like this. Helium, this is neon, this is argon, this is krypton. Its atomic number is 1836. Now we have 4d10, 5s2, 5p4. Now 36 and 46, 46, 48, 48 or 4 will be 52. This is krypton. Now the last one is polonium. We have to add 32, that is 84, and we will write it as electronic configuration. Here the fourth shell is also complete, so we have the 4f electrons filled in the 4f orbitals also. It is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14. 5s2, 5p6, 5d10, 6s2, 6p4. Now we will first count the number of the electrons: 2, 4, 10, 12, 18, 28, 30, 36, 46, 56, 60, 62, 68, 78, 80, 84. Now with the no to gas core, it is helium, neon, argon, krypton. This is xenon, 54. Now of xenon we have 4f14, 5d10, 6s2, 6p4. 54 और 14 हो गए 68, 78 हो गए 80, 84. So we have 4f14 यहाँ तक, and after this we have these are complete with this 4d के साथ. This is the electronic configuration of xenon. अब यहाँ पर you must not get confused कि यहाँ पर हमने क्यों xenon के साथ यहाँ ये दो लिए और ये लिए, because we have, while writing the electronic configuration of the xenon, actually the electronic configuration we are filling the orbitals according to the increasing order of the energy. लेकिन यहाँ पर जब हमने fill up किया orbitals को, then we have written them in their sequence. Sequence का मतलब ये है, if we write the Abel's principle, that is 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 7s, 7. इतने तक हम फिलअप करना है. So this is like this. This you have read in the 11th class. The first is which has the lowest energy, that is 1s. 1s के बाद actually we have to go here. This is 2s. उसके बाद 2p 3s. इसके बाद again 3p 4s. 3p 4s. 3d 4p 5s. 3d 4p 5s. 4d 5p 6s. 4d 5p 6s. 4f 5d. 4f 5d. 4f 5d 6p 7s. This is the increasing order of the energy of the orbital. अब अगर आप देखेंगे यहाँ पर how we have filled the orbitals according to their increasing energy. 1s, 2s, 2p, 3s, 3s, 3p, 3p. इसके बाद चूंकि 3 इसके बाद 3d आता है, इसके बाद 4s आता है. 4s completely filled होता है, 3d completely filled है. लेकिन अकॉर्डिंग टू द सीक्वेंस 3 पहले आना चाहिए 4 बाद में, तो हमने सीक्वेंस शेल्स के सीक्वेंस से इनको फिर अरेंज किया है. फिल अप we have filled the orbitals according to this Abel's principle, but we have accordingly then arranged them according to their sequence. तो 3D जो है इट इज ऑल्सो कंप्लीट, 4s भी कंप्लीट है, इसलिए हमने 3D पहले लिखा, 4s बाद में लिखा, फिर 4p, देन अगेन वी हैव 4D, पहले 4D आना चाहिए क्योंकि पहले 5s फिलअप होता है अकॉर्डिंग टू द आबाज प्रिंसिपल, लेकिन 5s भी कंप्लीटली फिल्ड है, 4D भी कंप्लीटली फिल्ड है, इसलिए हमने पहले 4D लिखा। और यहाँ पर अगर देखिए 4D के बाद हमें 5p फिलअप करना है, 6s फिलअप करना है, उसके बाद 4f में इलेक्ट्रॉन्स फिलअप करने हैं, लेकिन जब हम 4f में फिलअप करके जा रहे हैं तो 5s भी कंप्लीट फिल्ड होता है, 4D भी, 5p भी, 6s भी, उसके बाद 4f कंप्लीटली फिल्ड होता है, लेकिन सीक्वेंस के हिसाब से हमने पहले 4f लिखा, पहले 4D लिखा, फिर 4f लिखा, फिर 5s लिखा, फिर 5p लिखा, 5s लिखा, फिर 5p लिखा, राइट। उसके बाद आता है 5D। नाउ वी हैव रिटन 5D। 5D के बाद हमने सीक्वेंस के हिसाब से 6s लिखा है, 5D के बाद 6s, और 6p सीक्वेंस के हिसाब से। नाउ दिस 6p हैज 4 electrons and 4, this 6s is completely filled and 6p, क्योंकि यहाँ तक ही हम पहुँच गए, इसके बाद हमें 7s में फिलअप करना है, लेकिन ये लास्ट में आता है, तो 5D कंप्लीटली 10 इलेक्ट्रॉन्स इसमें आते हैं और इसमें 4 इलेक्ट्रॉन आते हैं, वो हमने लास्ट में 6p में 4 इलेक्ट्रॉन। यहाँ तक 6p से पहले तमाम जो है ऑर्बिटल वो कंप्लीटली फिल्ड है, इसलिए हमने इनको अकॉर्डिंग टू द सीक्वेंस अरेंज किया है। तो क्योंकि यहाँ तक हम पहुँचते हैं, दिस इज द इंक्रीजिंग ऑर्डर ऑफ द एनर्जी ऑफ द ऑर्बिटल्स, तो फिलअप करते करते हमें सिर्फ 4 इलेक्ट्रॉन बचते हैं, तो वो हमने 6p में फिलअप किए हैं वो 4 इलेक्ट्रॉन, तो 6p जो है इसमें 4 इलेक्ट्रॉन है, बाकी कंप्लीटली फिल्ड है। उसके बाद हमने अकॉर्डिंग टू द सीक्वेंस उनको अरेंज किया है। दिस वाज द इलेक्ट्रॉनिक कॉन्फ़िगरेशन। नाउ द एटॉमिक प्रॉपर्टीज। Some atomic and physical properties of the group 16 elements are: atomic and physical properties. Number one is atomic and ionic radii. Number second is ionization energy or enthalpy. Number third is electron gain enthalpy. Number 4 is electronegativity. If we take group 15 and group 16 elements, nitrogen, phosphorus, arsenic, antimony, bismuth, and oxygen, sulfur, selenium, tellurium, polonium. As we move across the period, the atomic size decreases. क्यों decrease होता है? Because the electrons get added in the same shell, the nuclear charge increases, and there is more and more attraction by the nucleus towards the outer shell electrons. So the group 16 size of the group 16 elements is smaller as compared to that of the group 15 elements, but as we move down the group, the atomic radii increases due to as the number of the shells increase. Same is the case with the ionic radii. Now, ionization enthalpy. The first ionization enthalpy of the group 16 elements is unexpectedly lower than that of the corresponding group 15 elements, whereas the second ionization enthalpy is greater than the corresponding group 16 elements. Why it is so? Because if we take the electronic configuration of the nitrogen, it is 1s2, 2s2, 2px, 2py, 2pz. It is 1, 1 and 1, and oxygen it is 1s2, 2s2, 2px, 2py, 2pz. This is 2. Here in the group 15 elements we have the outer shell electronic configuration ns2, np3, and here we have ns2, np4. This is more symmetrical and more stable. Electronic configuration as compared to the corresponding group 16 elements. So because of this more symmetrical, more stable electronic configuration, the ionization enthalpy of group 16 elements is lower than that of the first ionization. Ionization energy first. That means when we have to remove the first electron, we have to supply less energy to remove the electron from the group 16 as compared to the group 15, in spite of that they have the smaller size as compared to the group 15 elements, and number second, that they have 4 electrons in their outermost shell, whereas these have 3 electrons in their outermost shell. And because of the stable, more symmetrical and more stable configuration of the group 15 elements, the ionization and first ionization enthalpy of group 16 is smaller. It is less than IE ionization enthalpy first of ये group 16 है, ये group 15 है, whereas it is IE second is greater than IE second than group 15. And this ionization enthalpy decreases as we move down the group because the size increases and the number of the shells also increase. Now the second is electron gain enthalpy. The electron gain, the outer shell electronic configuration, or if we take the electronic configuration of the group 16 elements, they need only 2 electrons to complete their octet to have the stable configuration. So they take these electrons, therefore they have lower, they tend to have these electrons, and also because their electronegativity, because of their size, their electronegativity is greater than the group corresponding group 15 elements. This is why they have lower electron, they have more electron gain enthalpy as compared to the group 15 elements. But this is smaller as we take, smallest as we take the oxygen. The electron gain enthalpy of the oxygen is smaller as compared to the rest of the, it is the smallest as compared to the rest of the elements. It is because of the smaller size and the repulsion of the electron in the smaller p orbitals of the oxygen. And electronegativity, the electronegativity of the group 16 elements is higher than the corresponding group 15 elements. In fact, oxygen is the second most electronegative element after the fluorine, and it is electronegativity En is 3.5 of oxygen, whereas the En of fluorine is 4. So, but as we come down the group, the atomic size decreases and the value of electronegativity decreases. This is because they only need 2 electrons to complete their octet to have the stable configuration, and because of the smaller size as compared to the group 15, corresponding group 15 elements, so they have the electronegativity greater, only smaller than that of the halogen family. This is their electronegativity. This will do. Thank you.